Good afternoon, everybody. My name is Brad Hollister, and welcome to my presentation on optimizing Civil 3D data performance in Autodesk Construction Cloud. You might be wondering why I chose to talk about project data management today. Honestly, I've been wondering a little bit myself about that. I know, I do have experience over the years of training designers on design workflow and design processes. And, one of the lessons that I've learned in those experiences is that as soon as I start introducing project data management into the conversation, all the engineers, their eyes gloss over, their jaw hangs slack, and I quickly lose their interest. And so why would I choose that topic today? Well, I do have an interesting story to tell. At least I believe it's somewhat interesting. We started out trying to solve a problem, and I'll describe what that problem was and what we learned about the problem as we investigated it. And, through the process of exploring the problem, we came up with some unique ideas for solutions, and we expended effort trying to, put those solutions into practice in a way that makes sense in a design process. And we learned several things along the way. I want to share that with you, and then share with you some ideas and how you can use this in your design work in a daily workflow type of sense. So before I dive into the presentation today, I want to first share with you a little bit of information about Stantec. So if you haven't heard of Stantec before, we're a global leader in sustainable engineering, architecture, and environmental consulting. The diverse perspectives of our partners and interested parties drive us to think beyond what's previously been done on critical issues like climate change, digital transformation, and future-proofing our cities and infrastructure. We innovate at the intersection of community, creativity, and client relationships to advance communities everywhere so that together we can redefine what's possible. Now, my role at Stantec is as part of the Infrastructure Digital Practice Team. We're a group of 18 people, and we serve all of our North American offices in the Infrastructure BOU. So our Infrastructure BOU is one of 5 business operating units at Stantec. The others include buildings, energy, and mining, environmental services, and water resources. So the Infrastructure BOU is about 7,200 people, and our role is to not support software, but to support workflow, and in particular model-based design and BIM workflows on our projects. So we have a wide variety of projects, project scopes, wide variety of project sizes, and we help project teams assess workflows, improve workflows, assess project requirements, develop design processes that meet and exceed those requirements. This involves innovation, training, and support of our staff. And also, you'll see my 4th bullet there is deliver. We do have active work on our design projects. Several members of our team are, actively engaged in project delivery from any number of offices that have won work that, could use our help on the production team. And then our digital practice team also chases and, our own technology consulting projects. So that's one of my roles on the team is I manage our technology consulting efforts, where we have projects that we're a part of, such as the TxDOT Digital Delivery Program implementation or design software implementation at Pennsylvania DOT. So let me first set the stage here by describing the problem we were trying to solve. So let's take ourselves back to late autumn of 2022. We were coming out of the COVID pandemic and more people returning to the office, and we had worked our way through that period of a lot of people working through the network, but we had always felt that we were lacking in a common data environment that was effective for Civil 3D design work. The 2 options that we had been working with were ProjectWise and Autodesk Construction Cloud. Now, ProjectWise can be a very effective common data environment for Civil 3D design. We have several teams that were using it very effectively and really were committed to it, enjoyed it. We're singing the praises of ProjectWise for Civil 3D work. So it can be used effectively with proper workflow and proper best practices. One of the things that I've found in ProjectWise for Civil 3D is that it pushes people a little bit outside of the traditional or natural data management workflow. for Civil 3D. And that could be problematic if people aren't aware of these new rules, new best practices for how to use Civil 3D in ProjectWise. So it was an ongoing challenge for us to try to stay ahead on the education front to make sure that people were aware of these. And oftentimes what we were experiencing is people had already had experiences in the past with ProjectWise and Civil 3D that they that left them with a bad taste in their mouth. And so we didn't see ProjectWise as a long-term solution, but it was being used effectively on some of our projects, especially where project teams were well aware of best practices. But that downside of the lack of a natural Civil 3D workflow was something that we were trying to, find a better solution for. So we had been piloting Autodesk Construction Cloud in collaboration for Civil 3D within it since late 2020 when it released. And 2 years later, we hadn't graduated ACC out of pilot mode, primarily because of performance. We continually saw performance that didn't meet our users' expectation. And this is, again, in late 2022. And so we spent a lot of time investigating the reasons for that, looking for best practices to optimize performance. And that was the beginning of our journey. What we liked about Autodesk Construction Cloud is it did have that natural Civil 3D data management workflow. And we did see it as the common data environment of the future that would be preferred for Civil 3D design work, but it was the performance side of it in fall of 2022 that was preventing us from saying that it was ready for mainstream use and a wide variety of Civil 3D work. We had continued to pilot it. We had project teams that were committed to doing all their projects in it that really had developed a series of best practices, but even they wanted to see the performance improvements. And so we started on this journey of investigating what we could do to improve Civil 3D performance on ACC. One of the significant factors that we discovered during piloting of collaboration for Civil 3D that impacts performance was the way that the system and desktop connector software analyzes reference relationships. So if you're not familiar with ACC collaboration for Civil 3D, Desktop Connector is the desktop software that you use on the system that enables the cloud-based design collaboration to work. So you're using your desktop application of Civil 3D, and Desktop Connector synchronizes DWG files that are in a master cloud project on Autodesk Construction Cloud, synchronizes that data on an as-needed basis down to your local hard drive. And then Civil 3D itself works with that data on your hard drive. And so when we were using traditional Civil 3D data management workflows, perhaps on a network server from within the local area network, Civil 3D would typically, if you had a file open, it would look at the XREFs, the external references that are attached to that file, and it would look at the data references that are coming into that file. And it would just stop there. I'd like to call that the first order of referencing. However, the collaboration for Civil 3D system looks at nested references. With XREF, it does honor the overlay versus attachment process, and it considers that and how it analyzes XREF. With DREF, it always looks at nested references. And so what we would see is an extended series of data relationships that would need to be validated with many different actions that were happening in Civil 3D, definitely with file transactions. And if we didn't have perfectly maintained reference relationships within that data, if we had broken references, broken data shortcuts, misdirected, it would slow the system down further. It would try to validate these data inconsistencies. And because it was going through the extended data relationships, it would take a long time to work through those validated processes sometimes, validation processes. So the problems that we would create in data when we were working on a network server were not really impacting performance very heavily, those same types of problems would be much more problematic and much more impactful to performance in the collaboration for Civil 3D system. So I'm showing here, this is a file that we ran, the Reference Explorer tool from Desktop Connector on, and you can see where there's only 4 derefs and 4 xrefs coming into a given file. We're actually seeing, so that would be a total of 9 files. 8 files plus the active file in traditional Civil 3D working on network server validation processes. With collaboration for Civil 3D, it's 62 files because of those extended data relationships through the deref system, where it's looking at, let's say it's a surface file that we're looking at. It doesn't stop analyzing there when it finds that file that's the source of that surface. It might find that that file that's the source of that surface has 3 derefs coming into it and 1 xref coming into it. There's 4 more files, and then there's reference coming into those files, and so on, and so on. And so it keeps following those nested reference relationships all the way until you get to the beginning of the data flow. And that was seriously impacting performance. So to explain the difference between those two ways of analyzing references and validating the data, this diagram is showing a fictitious but realistic data structure that leads in a transportation project that leads to a plan sheet, right? And so we have different deref and xref connections to different source files, and a typical project environment with the plan sheet might have 1, 2, 3, these 6 references that I'm showing here in this diagram. But it's only looking at that first order of reference relationships. So for example, I'm showing a pipe network 1 drawing that's referenced, that's derefed into the plan sheet that we're looking at, right? However, that pipe network drawing might have surfaces, alignments, even profiles that could be derefed into it, right? And so if we look at how collaboration for Civil 3D analyzes these, again, it doesn't just stop at the first order of referencing. It looks at the nested relationships within the data shortcut system, within your data references, and it analyzes and validates those as well. These are things that we had discovered between 2020 and 2022, and we had determined that these were significantly impacting performance. And you can see here that all the extra work that needs to occur in validation, it's no wonder why it was slowing down performance. So this graphic here is trying to portray how this was impacting the data within a project. It wasn't uniform across the full project data structure. So in our existing condition model files, existing ground, the base map that shows the existing topography of the site, for example, oftentimes those files don't have references coming into them. They're really just dependent on the data that's in the file itself, and so they perform very well. And so you can see, when we're in the existing condition area of the data flow of a project, the heavy blue arrow on the bottom shows good, strong data performance in that phase of the project. We start doing some preliminary design work. Typically, it starts out with 2D geometry. We have a few references coming into those files, but again, the data hasn't developed a lot of depth to it yet, and the performance is still very strong, and there's very little data impacts when we're in that very early preliminary design phase. In a roadway design workflow, we're going to graduate from that into the 3D world. We're going to start developing corridor models, and that's where we start seeing some heavy impacts to the design process. We start seeing more weight to the references that are coming into those corridor files, and certainly we're developing a lot of things inside those corridor files. Plus they have a lot of traffic, so those corridor files can be at risk of small data corruption issues in the database. We might go from that to pipe networks, where actually all that corridor and roadway design geometry that we've developed feeds into the pipe network authoring process. And so those can really start to feel the weight of that. And at the very tail end of all of this are the plan sheets, which has all of this work referenced into it. And so you can see as we move through that progression of data flow, we see a cumulative effect of that data impact over the course of that flow. And so it's the plan sheets that suffer worse. Very often we would talk to project teams about that, and the modelers and the designers aren't feeling the same performance losses to data inconsistencies that are in the data that the plan sheet, the plan production group who are working with the plan sheets were feeling. So we very often talk about how our best practices that we adhere to in design maybe aren't as impactful for our performance of the files we're working on, but they're very impactful for the other people that are working on the team. So, a lot of those conversations help people understand and improve their practices in managing their data throughout the design process. And it's also tied into those extended data relationships. These impacts reflect, from the plan sheet reference relationships, the impacts there are coming from a large number of files throughout the data structure because of those extended relationships and the data validation related to it. So this is a very real effect that was impacting performance in collaboration for Civil 3D. So in addition to the extended data relationships, something else that we found that was impacting performance was circular reference patterns. We always understood circular reference patterns should be avoided, and we tried to create data structure that prevented that from happening. But it was really the release of the Reference Explorer tool within Desktop Connector that helped us chase these circular reference patterns down in ways that we never could before. We would try to manually visualize the file relationships and even diagram at some time to diagnose performance issues. Reference Explorer made that work very easy, and it really exposed to our minds the full extent of circular reference patterns that were occurring within our data structures. We found numerous instances working with design teams where it was just baked right into their everyday processes and had been for years. This circular reference patterns, you can see that this is a Reference Explorer diagram from a team. When I showed them the circular references they were creating, the response was, well, we have to work this way. This file needs to see that file needs to see that file. We have multiple disciplines moving design concepts forward, and they need to see the results of each other's work to stay coordinated as they went forward. And again, the circular patterns seem to be more impactful with collaboration for Civil 3D and the way it was analyzing data relationships between files compared to the past, where we were working on network servers. Civil 3D standalone as a desktop application didn't do this type of analysis, but the circular references were clearly slowing down file exchanges because of the validation processes. And we could see that by just disconnecting those circulars and seeing the performance differences that would occur, the performance gains that we would see by breaking the circular references. However, it didn't solve the problem that those workflows needed to have those reference relationships established for the different disciplines to be able to perform their work. So we needed a solution that addressed circular references if we were going to improve performance to the extent that we were hoping to be able to do. We started theorizing that a change to the way we're structuring our references could solve these problems, the circular references and the extended data relationships. This concept of indirect referencing that's being diagrammed here is what we started discussing. And it potentially solves both, right? So the idea here is that instead of directly referencing a model file, so a model file might be a base file showing, proposed roadway features. A model file could be a surface model file, it could be a corridor model file. And this indirect reference pattern, it could be established both with data shortcut and data reference system, or it could be done through XREF as well. And instead of directly referencing that model file, the idea is that we publish from that work in progress model file a reference source file that's a snapshot, a static snapshot of the state of that work when we publish it. So with XREF, it would be a visual snapshot of the visual state. For a data reference source file, what we envisioned was picking out the singular data shortcut object, or the data referenceable object. So, and putting that in a clean, empty DWG file. So for some types of references, it potentially could create efficiencies, just from the idea of separating the reference from work in progress. A proposed work surface, for example, or a corridor surface, for example, if we were going to deref a corridor surface, it has a lot of content in its source file. It's got corridors, for sure. It may have other types of references coming in, like existing ground, for example. And if we're just trying to reference the proposed work surface, all that other content that's in that file becomes baggage. So if we could just extract that surface from the work in progress model file and put it into a clean, empty DWG file and make that the source of our references, it would potentially, well, it would definitely break circular reference patterns. It would break that chain of extended relationships, and it's going to create smaller, lightweight reference source files that only have the content that we're trying to reference and not all the other baggage that's in our work in progress model files. And so you can see the different data structure as a result. This is a data set built off the same exact data. So we ran Reference Explorer on a sheet file. And the top right one is just the natural data structure given the workflow that's employed by this design team and what it creates. That very same sheet file with an indirect referencing pattern, you can see has a much cleaner data structure. It eliminates the circular references. It eliminates all those extended data relationships that need to be validated. It just brings everything to a first order reference. And it has the added benefit of removing from our reference sources all of the extra data, all of that extra baggage that we ordinarily get when we use traditional or direct referencing. So that was the idea that we settled on. It's not a new idea, indirect referencing. We had seen it used by some of our project teams in a limited sense already. But the challenge, and the reason it wasn't used more broadly, is that the workflow for creating these reference source files is cumbersome, right? And every time you want to update the state of a model and the way it's being viewed by the rest of the project, you had to go through this entire process of cleaning the file, redirecting all the references, through a file save as process. And it was very cumbersome, and it didn't seem practical to use it in a daily, everyday sense. The solution that we were looking for was, of that type, where we wanted to be able to improve performance across the board for all collaboration for Civil 3D use. And that the cumbersome nature of creating these reference source files was going to prevent that. So that was the problem that we settled on, that we wanted to solve, but we realized that we were going to need custom tools to make that reference source publishing process go more quickly. So with that idea in hand, we did some manual investigation, and we were seeing some performance improvements in a light sense, but we did see the workflow issues with creating the reference source files. So we invested in this idea, and we built some custom tools for our Stantec Civil 3D users that made the process of publishing a reference source file and reduced it down to just a couple of button clicks with these custom utilities. So we created an XREF utility that, with just a couple clicks would replicate the visual elements in model space of a DWG file to create an XREF source file that is static and disconnected from the work in progress model file. And a little bit more complex, we also created a utility to do this for data reference objects. So with the derefs, what we did is, no matter how many data reference objects existed in the active file that we were working in that model, when we created deref source file exports from that file, it would create individual DWG files for each of the deref objects that we wanted to create a source file for. So if we had a corridor, 2 pipe networks, 3 surfaces, all natively hosted within this model file that we were working in, when we run the deref utility, it potentially, depending on, what the user selected for export options, it would create an empty DWG file and then bring the corridor into it, an empty DWG file and bring the surface into that one. a different empty DWG file and bring a pipe network into that one. So it creates from template a brand new empty fresh DWG file that has these different data reference objects, and it puts it in a destination directory that's configured for the project. So essentially, instead of referencing these big, heavier weight deref source files, we're breaking those down at the object level to individual files for each one, and these individual files just had the minimal amount of data relationships to keep the integrity of that object, so to speak. And that's where we created the data shortcuts from, was these deref exports. And so it was a process to develop the tools that did that. And through the course of 2023, that was the work that we employed with it. And we started putting the tools into, pilot practice, so to speak, with specific projects that were interested in using this tool. And, we started building some experience using these, and some of the benefits that we found with indirect referencing when putting it into practice, it clearly was creating smaller reference source files, right? That one only contain the minimal amount of data that they need to contain for the object that they're supposed to be a reference source for. And there is efficiencies to that. In the course of publishing those objects, those reference source files, we were separating the reference sources from all of the data that's in our model files. And so those extended data relationships, where we saw nested reference relationships in the deref system in collaboration for Civil 3D being validated and maintained by the system, it breaks that chain immediately. And so it stopped the extended data relationship problem. Because it's stopping extended data relationships, by nature, it breaks all the circular reference patterns that are embedded in the workflows. So the project teams that told us we need to work this way, this file needs to be referencing that file, and that file needs to be referencing this file, so that these multiple discipline coordination reference patterns can continue to exist in the design process. It solves that problem without having the circular references, which again was another performance gain for us. So we were seeing performance gains in indirect referencing to the tune of about 25% faster files overall. And looking at the heaviest, most impacted files in the project directory structure, the sheet files, if you'll remember that data momentum slide, that's where we were seeing about that 25% gain in file open times. So definitely we were seeing some performance improvement, which we found, promising and beneficial, of course. At the same time, during this period of 2023, this collaboration for Civil 3D system itself became more efficient. New versions of Desktop Connector were released that were less sensitive to those performance issues than the earlier versions of Desktop Connector. So where we're seeing potentially greater performance gains in earlier versions of Desktop Connector, because of the advancements of the system and the improvements in the software, the benefits were being reduced. Now, that wasn't necessarily a bad thing, right? We definitely welcome the performance improvements across the board, but it did reduce the beneficial impacts of indirect referencing and the tools that we were creating. However, through the course of studying this in a production sense, we did realize that there were other benefits to the indirect referencing patterns as well. When we have complex design environments with a lot of multidisciplinary coordination as part of the design process, especially when we have extended teams that maybe aren't geographically in the same location, they don't sit in the same office. Sometimes we'll have extended teams that extend outside of our firm, and either we're a sub-consultant to a project, or we have sub-consultants on our project that are all collaborating together on the same design process. The management and maintenance and administration of keeping project data clean and orderly becomes more and more challenging. The more cogs you put into that wheel, so to speak, the more difficult it is for our CAD managers to make sure that the data is performing as well as it can and it's structured correctly throughout. We start to see reference definition issues is very common. The very orderly structure of this process of indirect referencing itself creates a system that's easier to maintain and administer from a CAD manager standpoint. So some of the practices where we would see sloppier practices that lead to incorrect reference definitions, easier to catch, easier to diagnose, and easier to resolve. So that was definitely a benefit. Another benefit that we realized through the course of this that wasn't necessarily on our radar screen to begin with is that it creates a different data traffic pattern in the design process. So if you'll remember when I introduced, collaboration for Civil 3D and ACC and how that works, it involves a master project data set that's in the cloud, and then Desktop Connector, which is a local software, synchronizes the data on our hard drive to that master project in the cloud. So when we have 50 or 75 designers working out of the same Civil 3D data set, and everybody is referencing work in progress model files, and people are working in those work in progress model files, and remembering that, a good Civil 3D practice is, not just to save your work at the end of the day, but to incrementally save your DWG files as you're working. It ensures that, if you had some kind of software glitch or system crash, that you're not going to lose a large amount of work if you're creating these incremental saves. Well, with the work in progress direct referencing patterns and with many, many users involved in a project environment, that can lead to high levels of data traffic. For each designer that's working in the system, where Desktop Connector is often synchronizing files and files and files because there's just a high frequency of file saves happening throughout the data set and because of those extended data relationships. Well, by using the indirect reference pattern, what we see is just a more static reference source file system where all these incremental saves in the DWG file are not necessarily being published to a new reference source file. So now when I'm working in my corridor, if I'm working on a surface file, every time I save the DWG file to preserve my work, it doesn't necessarily create a data reference that needs to be synchronized everywhere else that this file is, or that object is being derefed. Instead, I might work through 5 or 6 or 12 or 15 incremental DWG file saves without publishing the results of my work and replacing the current reference source file. So all of a sudden, the data traffic synchronizing all these DWG files to each person's machine is significantly reduced. That can be a major factor in production environments that improves overall system performance, the idea of better data traffic patterns. That was one that we hadn't thought of initially, but it's definitely, a benefit that this process enjoys. And finally, the entire design process from a designer standpoint, it becomes a more controlled environment. It's easier to structure and manage. Just the idea that we pick and choose when the rest of the project team sees the results of our work. Instead of seeing our work in progress with every file save, we get that modification in the DWG file to a static point where we're ready to share it. And then we publish the new reference source file. It's a new way of managing the Civil 3D design data within a design process that's very friendly to design structure and organization from a team standpoint. So all of those things are, things that we are enjoying about this new process that we've, developed for managing our Civil 3D data. Now, there are some downsides to it, certainly. One of them is it's just a new process, right? This is foreign to Civil 3D users, and they're going to have to learn how to structure and think a little bit differently in how they're managing their Civil 3D data. So it's certainly just having to introduce a new workflow and train people, that's certainly a downside. One of the more significant downsides to indirect Civil 3D referencing is that it really does benefit most when you have custom tools that automate publishing processes for source files. And not everybody is going to be able to, build those custom tools. So that's definitely a downside that I would like, everybody to just be aware of. However, I do feel that, even without those custom tools, there are ways to use this idea in everyday Civil 3D work. But first of all, if you're wondering how to improve project data performance and collaboration for Civil 3D, before you do anything else, make sure that your reference definitions are correct. That's always going to slow the system down. So if you see a flag next to a data shortcut, ask yourself why that flag is there, investigate it, and solve that data issue. If you have broken X references, detach them or redirect them, repath them to the correct file in the correct location. So all those incremental little issues that we build into the data structure through sloppy practices impact performance, and that is absolutely low-hanging fruit. Everybody knows and understands reference definitions. It's not rocket science. And making all those reference definitions correct throughout the project as just standard practice, that is absolutely the number one thing that you can do to improve performance in the system. However, if you're looking to employ the idea of indirect Civil 3D referencing within a project workflow, and you don't have these custom tools, I would suggest think about your data structure, the type of project design that you're doing, and what files seem to have a lot of extra stuff when you're referencing them that you don't necessarily need. It's just extra baggage to that reference definition. Thinking about the Wisconsin DOT roadway design workflow, and any roadway design workflow in general in Civil 3D, and really a lot of site design as well, it's proposed surfaces that can have a lot of data inertia behind them. The process to get to that point of having a surface model has a lot of history behind it, starting from the existing condition model all the way through to that surface model. There's a lot of extra information in those extended data connections, but there's also a lot of information in the work in progress model file itself that sometimes that we're grabbing these surfaces from. So that extra data can slow down that reference connection. So immediately you can use proposed surfaces through a land XML file exchange into an empty DWG file as a way to replicate the automation that we've developed custom tools for to use indirect referencing. Proposed work surface files is definitely one that I would take a look at. XREF, if you're trying to eliminate circular references within your native workflow within project teams, yet you still need those connections, XREF is also an easy manual workflow for creating external reference source files. You can easily W block the content from model space to an empty DWG file that doesn't have references within it, so that the models themselves can have the references they need for developing and continuing to develop the design concept, but the reference sources that we share with the rest of the project team are disconnected from that. It's a simple W block process can achieve that. So those are two ways that you could employ it. Overall, on our journey of developing this concept, what we saw was an evolution of the collaboration for Civil 3D software system as well, where Desktop Connector and ACC improved their performance in managing live Civil 3D project data as well. So some of the benefits that we described for indirect referencing are less than they would have been 2 years ago as a result of the improvement of the system. And that's a great end to this story, really, that we do see the system itself improving significantly over the past couple of years, and the impacts of some of these issues that we were trying to resolve are much less disruptive now to ordinary daily project workflows. But that's the story that we have. That's the journey that we went through in trying to solve that problem. How do we make Civil 3D work better in ACC? And so just bringing me back to the beginning of the presentation, we talked about those factors that were affecting Civil 3D performance. I laid out a new structure to DWG referencing patterns that does improve performance more greatly, I think, in 2022 and the way the system was operating then than today. However, there are still performance gains to be had. And then there's other project management and project data progression benefits that we talked about as well. And then finally, I shared a couple of ideas on how to use this indirect pattern to referencing in daily work in Civil 3D without custom tools. So I'd like to thank everybody for joining me in this presentation today, and I'm ready to take questions.